2 gram zinc react with excess hydrochloric acid. Calculate A. The number of moles of hydrogen liberated. B. The volume of hydrogen liberated. Solution. The reaction is like this: 1 mole of zinc solid react with 2 moles of hydrochloric aqueous to give zinc chloride aqueous plus liberation of gas 1 mole of gas hydrogen. For the question A, the relative atomic mass of zinc is 63. Therefore, the number of moles of zinc in 2 grams of zinc is now 2 over 63, which will give us 0.32 moles. From the above equation, 1 mole of zinc gives 1 mole of hydrogen. Therefore, 0.032 mole of hydrogen will have a volume which is equal to 22.4 times 0.032, which will give us 0.716 dm cube. For the answer to the question B, 1 mole of any gas at SCP has volume of 22.4 dm cube. Therefore, 0.032 mole of hydrogen will have a volume which is equal to 22.4 times 0.32, which will give us 0.716 dm cube. Example 9. In the experiment involved the displacement of hydrogen from an acid by zinc. The following results were obtained. Atmospheric pressure is equal to 765 mm of mercury. Room temperature is equal to 294 Kelvin. Mass of zinc used is equal to 0.095 gram. Volume of hydrogen evolved is equal to 35.1 cm cube. Calculate the molar ratio of the zinc to hydrogen. Solution. Using the general gas law, P1V1 over T1 is equal to P2V2 over T2. The volume V2 hydrogen liberated at SCP is then 765 for P1 times V1 335.1 divided by T1 294, which equals to P2 760 times V2, which is unknown, divided by T2 273. Therefore, making V2 the subject of the formula, we have that 765 times 35.1 divided by 294 times 273 divided by 760 will now give us 32.8 cm cube. Number of moles of hydrogen evolved will now be 32.8 divided by 22.4 times 10 raised to power 3, which will now give us 0.00146 moles. Number of mole of zinc will now be equal to 0.095 divided by 65, which will give us 0.00145 moles. The molar ratio of zinc to hydrogen is now 1:1. Chapter 10. Miscellaneous calculation on gas law. Miscellaneous calculation based on the gas laws. In calculation involving gas volumes, it is better to work in moles. Conversion into volume can then be affected. Bearing in mind that 1 mole of a gas at SCP occupies 22.4 dm cube. Example 1. Find the smallest volume of oxygen required to burn 2 dm cube of ethane. Calculate the volume of carbon 4 oxide formed. Solution. Formula for ethane is C2H2. Equation of the reaction: C2H2 plus 7 over 2 O2 will give 2CO2 plus 3H2O. Reacting moles: 1 mole of ethane react with 7 over 2 moles of oxygen to give 2 moles of carbon 4 oxide. Reacting volume at STP is 22.4 dm of ethane react with 7 over 2 times 22.4 dm of oxygen to give 2 times 22.4 of carbon 4 oxide. From the above equation, 22.4 dm of carbon of ethane will need 7/2 times 22.4/1 times 2/22.4, which is 7 dm cube of oxygen. Also, from the equation, 22.4 dm cube of ethane gave 2 times 22.4 dm cube of carbon 4 oxide. 22.4 dm cube of ethane will give 2 times 22.4/22.4 times 2/1, which will give us 4 dm cube of carbon 4 oxide. Example 2. Calculate the volume of oxygen at 227 degrees centigrade and 740 mm of pressure, which could be obtained by heating 10 grams of potassium tetraoxochlorate. 5. Solution. Equation of the reaction. Heating potassium tetraoxochlorate 5 will give potassium chloride and oxygen. Combining masses volume. Now 2 times 39 grams of potassium plus 35.5 grams of chlorine plus 48 grams of oxygen, that is 16 times 3, will give 3 times 22.4 dm cube. This equals to 245 grams of potassium tetraoxochlorate 5 will now give 67.2 dm cube of oxygen. From the equation above, 245 grams or 2 mole of potassium tetraoxochlorate 5 yield 67.2 dm cube of oxygen at STP. Therefore, 10 grams of potassium trioxochlorate yield 10 times 67.2 divided by 245, which will now give us 2.74 dm cube of oxygen at STP. By using the general gas equation P1V1 over T1 equals to P2V2 over T2, we can find the volume that 2.74 dm cube of oxygen that at STP will occupy at 27 degrees and 740 mm pressure. Thus, making V2 the subject of the formula, you have P1V1 T1 over P2V2 T2, where P1 is 760 mm of mercury, V1 is 2.74 dm cube, T1 is 273 Kelvin, P2 is 740 mm of mercury, T2 is 273 plus 27 which Kelvin, which will give us 300 Kelvin. Therefore, V1, which is equal to 760 for P1 times V1 2.74 times T2 300 all over P2 740 times T2 273, making the computation to become 3.09 dm cube. Volume of oxygen obtained at 27 degrees Celsius is and 740 mm mercury will now be equal to 3.09 dm cube. Example 3. 30 cm cube of methane was exploded with 70 cm cube of oxygen and at volume measured at room temperature and pressure. Calculate the volume of each residual gas. Solution. Equation of reaction. Methane reacts with 2 atoms of oxygen to give carbon 4 oxide and 2 atoms of water. Combining volume, 1 volume of methane reacts with 2 volumes of oxygen to give 1 volume of carbon 4 oxide. 30 volume of methane reacts with 60 volume of oxygen to give 30 volume of carbon 4 oxide. It follows therefore that 30 cm cube of methane requires 60 cm cube of oxygen to give 30 cm cube of carbon 4 oxide. Original volume of oxygen is 80 cm cube. Therefore, the volume of the residual gas is as follows. Residual oxygen is 30 minus 60, which will give us 20 cm cube. Residual carbon 4 oxide is 30 cm cube. Residual methane is 0 cm cube. Volume of methane left